This video is about mechanics, Newton's second law of motion, the simultaneous equation. So the simultaneous equation is going to deal with one object pulling another object. It doesn't matter what it is, whether it's an aeroplane and a glider, or it's two boxes, or it's a caravan and a bakkie, it doesn't matter, but two objects that are pulling each other where there is the force of tension between them. So here's an example. Let's say we have two boxes. The first box is 7 kgs with a frictional force of 20 newtons. The second box that is pulling it is 12 kgs with a frictional force of 25, and the applied force on the 12 kg is 60 newton. So the first thing we need to look at is the free body diagram for each. So here is the normal force always and the gravitational force always. And then this 7 kg box is pulled to the right by tension, and friction will act opposite to the motion. Then the 12 kg box has the applied force of 60 newton. It has the normal force and the gravitational force. Then on this side, acting to the left, is the tension as well as the friction that is being experienced. So this one will be 5 marks if they ask for the free body diagram of the 12 kg box, and if they ask for the free body diagram of the one that is being pulled, which is 7 kg box, it will be 4 marks for the 4 forces. Now, the first thing that you need to do is to identify the net force on both of these objects. So net force is dealing with what? It's dealing with the forces in the horizontal. That means we are dealing with these forces here. And we are dealing with these forces here only. We are not looking at the forces in the vertical. So step 1 is to start with F net is equal to MA. And we know that F net is the forces, the applied force minus the forces acting opposite to it. So for this 7 kg box, it will have tension minus the friction is equal to the mass times acceleration. For the 12 kg box, it has one more force. So that is the applied force minus the tension minus the friction is equal to the mass times acceleration. This is now for the 12 kilo box. Now let's substitute the values that we have. We do not have tension. We have friction of 20 and we have mass 7A. Here we have an applied force of 60. Tension we have no idea. Friction of 25 is equal to 12A. Now, this formula on the left-hand side, we can transpose here and get T is equal to 7A transposing negative to positive plus 20. This is equation number 1. Then we have to substitute this into that T there. So it means now that 60 minus T, which is now 7A, let me write that properly, which is now T, but we have the value of it because we've already equated it there. So 7A plus 20, that is T, minus 25 is equal to 12A. Now what do we have to do? We have to multiply that negative sign inside, so we must get rid of the bracket. So it will be 60 minus 7A minus 20 minus 25 is equal to 12A. So now this is 45. So 60 minus 45 is how much? Is 15. So it is 15 is equal to 12A plus 7A. So that's 19. So we have 15 over 19. So A is going to be equal to 0.7 9 meters per second squared, right? And that's a simultaneous equation.